Now in part 2, we're going to talk about subtracting integers. Welcome to Mind Over Math. We're trying to illustrate first what an integer is, and second, using chips, illustrate why signs end up positive or negative in either addition or subtraction problem. Hi everybody, thanks for stopping in. Let me remind you to subscribe, like the video, and comment down below with ideas that you have for future videos or questions you might have. Thanks. Now subtracting is basic guideline is you turn it into addition. And that's what I'm trying to show you on this. A subtraction problem easily can be turned into addition. As explained in part 1, I'm using chips. I put them on a number line to illustrate how that would look with a number line. We talked about the zero pair, which has a charge of 0, and 1, 2, 3, and 4. So these chips are the way to teach this. So first thing we want to get is to subtract positive and negatives. Any minus sign is turned into an addition sign by two possibilities. If it's minus a negative, then you must turn that into 5 plus a positive 2. It's called the double negative. It's also true in English. A double negative ends up being a positive statement. Next choice is you're subtracting a positive. All you do is switch the positive and the subtract sign. This is a subtract positive. Now it's add a negative. You switch them. So get this. 1 minus a negative 1 is the same as 1 plus a positive 1. Minus a negative becomes plus a positive. Now I just have an addition problem. I'm going to use my add rules. Two positives add up to 2. 1 minus positive 1. Again, minus becomes a plus, positive becomes a negative. This negative 1 is this switching of these signs. Okay, so now I'm adding two opposites, so the solution is 0. Negative 1 minus a positive 1. Again, now the signs switch. Subtraction becomes addition. Positive becomes negative. I'm adding two negatives. The answer is negative 2. Does that make sense? Let's see that again. Negative 3 minus negative 2 turns into 3 plus a positive 2. Minus a negative becomes plus a positive. Illustrated, 3 plus 2 is 5. Try it again. Negative 2 minus positive 2. Now there may not even be a positive on that 2. There just may be a minus sign. But I can rewrite it with a positive, and then I switch these two. I switch them. Plus a negative. Now I'm adding two negatives. So the answer is negative 4. This may be the way you see this one above written, 4 minus 3. In your mind, that means a plus 3. So we switch 4 plus a negative 3. That minus sign became the negative. The plus sign, which isn't written but it's there, becomes addition. So now I'm doing 4 minus 3, which is 1. So you take every subtract problem and you turn it into an addition problem by one of these 3 methods. These are about all that can happen right here. Now the front numbers can have positive and negatives on them. So 3 minus positive 4 turns into 3 plus negative 4. So I have 3 minus 4 is negative 1. You subtract them. You subtract. Even though I turn this into an add, I now have opposite signs. When you have opposite signs, you subtract the bigger charged quantity, 4, minus 3. These are also called absolute values. The absolute value of negative 4 is 4. 4 minus 3 is 1. The sign of the larger dominates. Negative 4 minus 5, again, this is a way you'll see it written. You can understand a positive 5 right here, minus with a subtraction there. So negative 4 plus a negative 5, we switch these. So now I'm adding two negatives. I add them. And once again, negative 5 minus a negative 2 minus a negative always turns into plus a positive. We have negative 5 plus 2 is negative 3. Thinking in terms of without chips, that's 5 minus 2 is 3, but the charge on the 5 is much greater. The sign stays negative. Change a minus to addition using these two rules. You now have an add problem and you follow all of the add rules. So here's some problems again. Write them down. Check yourself. Write them on paper. Check yourself right now. Next slide. I'll show you the steps and the answers. I'll pause. So now the solutions work accordingly. Every time you see a minus or subtract sign, change it to an addition sign. There is a sign switch when you do that. So in the first case, 5 minus a positive 4 is the same as 5 plus a negative 4. The signs are opposite, so you subtract them. The larger quantity is a positive on the 5, so the sign is positive. Negative 18 minus 3 is the same as negative 18 plus a negative 3. Now I see negative 18, negative 3 are like signs, so we add them. Negative 14 minus negative 8, again, you turn the subtraction sign here into an addition sign and you switch these to a negative. Negative 22. 9 minus a negative 11 is 9 plus a positive 11 is 20. Negative 6 minus negative 7 is equal to negative 6 plus a positive 7 is 1. Again, you subtract them. The larger sign is on the 7. Negative 27 minus positive 2 turns into adding a negative 2. Two negatives add together and gives you negative 29. So this is a part 2. Now subtracting integers. The same will work with fractions and decimals. Whichever is greater will get the sign. You may want to go back to part 1 on adding integers using the chips, or to another part which is solving equations with integers using the chips. Thank you. In the upper right hand corner, make sure you subscribe. In the upper left hand corner, make sure you check out other videos. Likes are below and make comments on topics you need.